Okay, let's dive into this. Welcome to This Explainer, where we're going to unpack one of history's most absolutely terrifying, centuries-old unsolved mysteries. It's a phenomenon hundreds of millions of people have heard named at least once: spontaneous human combustion. Today, we're zeroing in strictly on the historical paper trail and the cold, hard forensic science to deconstruct exactly what happens when a human body is inexplicably reduced to a pile of ashes.
I want you to just sit with this question for a second. Can a human body actually ignite from within? I mean, for centuries, investigators have walked into closed, completely secure rooms and discovered a scene of absolute dread. We're talking about a victim entirely incinerated, yet the rest of the room, sometimes even the chair they were sitting in, or a newspaper resting right next to them, remains totally untouched by the flames. It completely defies our basic understanding of fire behavior, and it sets this deeply eerie atmosphere that has haunted the public imagination for generations.
To really grasp the horror coroners faced during these Victorian-era inquests, you have to hear this historical account of Grace Pett. She was a fishmonger's wife from Ipswich, discovered by her own daughter in 1744. The official report reads, "The fetid odor and smoke which exhaled from the body almost suffocated some of the neighbors. The trunk was in some measure incinerated and resembled a heap of coals covered with white ashes." I mean, wow. These visceral, incredibly macabre descriptions of ash piles are just scattered all throughout the public record office, and they left officials completely baffled. Now, what's really interesting here is the sheer impossibility of the visual evidence. Take the 1966 case of 92-year-old Dr. J. Irving Bentley. His torso was entirely destroyed. I'm talking reduced to ash that actually burned a hole straight through the floor. Yet, right next to that burn zone, the victim's lower leg, still wearing a shoe, completely intact. Even more baffling, his aluminum walker and the nearby bathroom fixtures weren't touched at all. It's almost like the fire was perfectly contained to just him.
And this brings us to an impossible pattern that investigators kept documenting across completely unconnected jurisdictions, from Bavaria all the way to Kentucky. They were seeing extreme, localized heat capable of calcinating human bone. Just to put that into perspective, that usually requires the massive, intense temperatures of a commercial crematorium. Yet this destruction was confined strictly to the body itself, with unscorched surroundings and absolutely zero obvious external accelerants. It was such a massive anomaly that in an 1869 British Medical Journal review, surgeon Benjamin Richardson flagged it as the one single category of death the Victorian Inquest system had no procedural framework to classify.
So the historiographical roots of this myth run incredibly deep. The documented case record stretches all the way back to a 1673 account by Danish physician Thomas Bartholin. Jump forward to 1852, and deposition transcripts from the inquest of John Belt of Aldgate described a body reduced to ash while the wooden chair right beneath him remained entirely unburned. That exact same year, Charles Dickens popularized the phenomenon in his novel Bleak House, and the mystery just kept persisting right up to the highly publicized 1951 Mary Reeser case. For a long, long time, the debate over what was actually happening was fiercely divided. On one side, you had these wild paranormal suspicions. Medical writers threw around terms like alcoholic impregnation, which is the honestly rather absurd idea that heavy drinkers saturated their tissues with so much booze that they essentially became walking Molotov cocktails. But on the other side, you had rigid, rational skepticism. Critics, most notably the German chemist Justus von Liebig in the 1850s, insisted that the human body simply contained way too much water, making self-ignition a complete scientific impossibility without some massive external heat source. To finally solve this mystery, we have to pivot to a groundbreaking 1984 reanalysis by forensic scientist John Dehaan, which was published in the Journal of Forensic Sciences. He proposed a complete mechanical explanation known as the wick effect. This is a cold, clinical mechanism where a victim's own liquefied subcutaneous fat is absorbed into their charred clothing. The clothing then acts exactly like the wick of an old-fashioned oil lamp, providing a continuous, localized fuel source. It literally turns the body into an inside-out candle. Let's walk through the gruesome mechanics of this step by step. First, an external heat source, and we're talking something as small as a dropped cigarette or a pipe ember, chars the clothing and cracks the skin. Second, that heat melts the subcutaneous fat right beneath the skin. Third, this liquefied fat seeps straight into the charred fabric, basically acting as a wick. And finally, because the fat is providing this steady stream of fuel, a slow, smoldering fire is sustained at temperatures between 500 and 800 degrees Fahrenheit, and it can burn for up to 12 hours as long as that fuel is present.
So the crucial point here is that this isn't just some hypothesis. It is entirely reproducible. In 1989, Dehaan actually demonstrated this for a BBC science program called QED. He took a pig, which happens to have a fat distribution very similar to a human's, wrapped it in a cotton blanket, placed it on a sofa, and ignited it with a small fire. Well, this experiment perfectly replicated the wick effect. The fat fueled a slow, localized fire that completely consumed the remains but barely damaged the surrounding room. This is what led most forensic pathologists to finally accept it as the definitive answer.
Now, that explains the localized fire, sure, but it leaves us with an incredibly complex question when it comes to forensic taphonomy. How exactly does a slow, smoldering fire of only 500 to 800 degrees Fahrenheit cause such extreme, calcifying destruction to human bone? Especially when we know for a fact that modern crematoriums require temperatures well over 1,500 degrees to achieve the same thing.
Well, it turns out bone doesn't just burn. It undergoes a profound chemical transformation. First, dehydration strips away the water. Then, during the decomposition phase, the organic collagen is destroyed. After that, the actual inorganic components begin to chemically alter in a phase called inversion, until they finally fuse together. This total biological destruction can actually happen in average house fire conditions, provided it's sustained long enough by that wick effect.
Let's move to how this builds, because due to these chemical changes, bone color literally acts as a precise heat signature for fire investigators. At lower temperatures, the bone turns yellow or brown. As the heat increases and we get into that decomposition phase, it shifts to black or gray. And when exposed to prolonged intense heat, it turns a calcined white. That white color is the telltale sign indicating the complete and total removal of organic matter.
And this brilliantly illustrates the sheer destructive power of fire on the human skeleton. When you look at an unburned humerus bone next to its calcinide match after controlled burning, the dimensional change is just immense. The dehydration and loss of organic components can cause massive shrinkage and mass loss, sometimes over 35%. It completely twists and fractures the structural integrity of the bone. This perfectly matches the impossible destruction coroners were finding in those historical ash heaps.
Finally, this science seamlessly resolves the final, arguably most famous visual anomaly of these cases, those surviving feet and lower legs. The simple physics of fire behavior dictate that heat rises. The victim's torso, which is rich in subcutaneous fat, sits directly in the active combustion zone. However, our lower legs and feet contain very little fat to fuel the fire. Furthermore, as the chair collapses and the body slumps, the legs typically fall downward onto the cool floor, meaning they entirely escape that rising heat column.
So for decades, the wick effect seemed to close the case entirely. But in 2008, a thermodynamics study out of the University of Sheffield quietly challenged this forensic consensus. Their peer-reviewed data showed that replicating these specific char patterns in laboratory conditions actually required an initial external ignition temperature that no accidental domestic source, like a dropped pipe or a cigarette, could realistically supply. So while the paranormal myth of spontaneous combustion might be thoroughly debunked, you have to ask yourself this. If the physics don't quite add up to a simple household accident, what exactly ignited these horrifying infernos in the first place? It seems the science hasn't quite finished with this mystery after all.